Okay, so let me see if I can go back and open that page. What was the number again?
Number 16 on the homework, it was in the book. Oh, no, it's not a problem from the book. It's
Okay.
a similar problem, 2.25, but it's got a little bit different numbers.
Oh, it says my session's expired. Okay, so why is my session expired? Let's do this again. You know what? Maybe it times me out or something. So there it is.
Ooh, what's that quiz do? Oh, you know what it is.
Yeah, it's on the, what's the week Friday after the
Is that one?
11th? Is it that one?
Yep.
Okay, so maybe, I wish the pictures, okay, this did the same thing. Here's the description, and then there's the same thing. The words are the same.
Yeah.
So that I got
The description was, it tells you, actually, you don't even need that, it's just component portion U, which is in that section there.
So is it, okay, so he wants to know AB, down AB, and then AC. Does he give me my angles? Oh, yeah, there they are. I'm sorry. They're right there.
He wants to know theta and the magnitude of AB, or beta A, depends on which one.
He wants, okay, so he wants to know this?
Yep, and he wants to know theta.
Oh, this theta.
Yep.
Oh. Okay. So he's got 500 pounds, and then he puts it in there. Okay, so let's see. The 500-pound force is to be resolved into two components, acting along the axis of the stress, this one and that one. Okay, then what more does he say?
There was a thing on the very top that
Oh.
the component force along AC is required to be 390 pounds directly from AC.
Oh, so this is supposed to be
390.
390. Okay, I was about to say, if he's asking me for finding theta, there's not enough information there. Okay, all right, so now I'm with you. So let's see if we can do this. Okay, here we go. So this is 390. And this one's got to come along here. So this one has to be the same as, yeah. This one's got to be the same as that one and that one put together. Okay, so, well, first of all, I think I got it the reverse direction. So I think it's supposed to be that, and it's supposed to be that. But, okay, that's the force in the member, but in order for them to, this is kind of a weird the way he does it. Okay, so you do this, you do that. So now, let me move my 390. And now, so I got my 390, right? And now I can, if I could move that, let's see if I can make it in parallel. So this is supposed to be that vector just moved over. I don't know. So let's make it go the whole way. And then this is, I don't know that this is gonna, I don't know that the angles are gonna work out, but you know. So you got a component like this. You got, okay, so let's see if I can redraw it. 500. $390, and I do not know the angle between here and here, but I do know this, and I do know, okay, so at this particular point, technically, you know, it doesn't say anything about, in other words, I could draw a line here, or here, or here, but it has to be 60. This is probably not going to be the scale, I'm sorry. So I'm going to take this, move it over, about like that. Okay, so now this is going to be, move it to there, and that's 60. Okay, so now if I got, okay, so if I got 180, take away 45, and then take away 60, what do I get? Any idea? If I did that, I'd have to walk over to the computer. days. I got 75 there. Okay, so this is one of those things where if I'm doing it this way with the vectors, which I usually don't, but since, you know, it is what it is, and I can do it the other way too. Since I jump across here, I can jump across here and then jump across there. But that didn't tell me what this one was yet. So in other words, I don't have the proper information. Yeah, so what I can do is I can do this. Sine of 75 over 500 equal to 390 over sine of the question mark. So we'll just do it as we go through. We'll just, so arc or inverse sine inverse of the question mark, which will be 390 over 500 times the sine of 75. What's that equal to? Oh, my eyes are no good either.
All right. Got these glasses I qualify for a seeing eye dog. Okay. 390 over 5.
Sine of 75. 2.685? That's the angle?
Oh, no, I'm sorry, that's the
okay.
parentheses part.
Oh.
I need to do the arc side of that.
Hey, wait a minute, that can't be.
48.88.
Okay. That sounds about right. So what is 180? Oh, sorry. 10 minus 48. So what's 180 minus take away 75, take away.
6.12.
Okay. So, yeah. Well, actually, he's wanting it from right there.
Yeah.
So what you got to do is you got to,
Subtract 45 from that.
right, you got to take your 45.
Which makes 11.1, which makes us the correct answer.
Oh, okay. I've already forgot the, what'd you say, 56 point something? Anyway.
56.12.
Okay, so that's the total answer. So that was the correct answer? That's
Yeah.
Okay.
Now, see, I was trying to do it with putting it into components.
Yeah, and that's what I was going to start, but then I started, you know, thinking about drawing the angle, and I was like, well, I'll just draw the.
I couldn't get my drawing to look right, and I gave up on that and went to components.
Oh, okay.
Ended up with the right magnitude for the force of AB, but every time I try screwing around to get the angle, I kept coming up with minus 84.1 degrees.
Oh, wait a minute. 84.1?
I believe
What's 90 minus that? That's not right.
that's
Okay.
not- it's not right.
Okay. All right.
It almost felt right, though.
It did feel right there for a second.
All right, well.
Okay. Well, you should be able to get it that way too. You should be able to get
Well,
that.
now that I've seen it this way, maybe I can combine them both and
Yeah.
work it back to do it the other way. 'Cause
Yeah.
I know I was on the right track, but for some reason I was getting stymied.
Yeah. And that's the same thing happened with that other problem. That other problem, you know, and I just started working it. I was like, I got stuck in the sense that my brain was like, half my brain wanted to do components and the other half wanted to do the vectors. And then I just sort of said, okay, I'll do the vectors. And then I'll do components. I don't know.
I kind of default to vectors because it seems like I don't have to do quite as much trig if I or not vectors, components.
Yeah, that's what I do too. I prefer that way, but there are times where I'm willing to mix them. Wait a minute. So did we do? That's the fluids one. Did you have any question on the fluids one? Let's see. Let's get rid of that.
I haven't done enough to really be confident in my questions.
Oh, okay.
I could ask them basic ones, but not serious much.
Well, all of these had enhanced with hints and feedback. This one doesn't. Let me just look at what that is. Oh, the viscosity of that oil is mu is equal to that. Which this is what they're doing in their class too. It has a description, but then the symbols show up down here. It looks right down here. It looks funny up here because when you type in is mu, you're like, okay, but that's supposed to turn into a Greek letter mu. Specific gravity has determined its kinematic viscosity. Answer in SI, express your answer in feet. So in that one, okay, so he's got two viscosities. One is the kinematic and one's the dynamic. Now I should go back to the book because I can't write. Does he write the symbol? I cannot write the symbol right. Yeah, so that's kind of what it looks like maybe, but this part might be closer together. And all it is this. So what he's told us is this one.
Mu over pressure?
Mu over the density.
Density, not.
Yeah. So you just take your 0.1 is Newton seconds meter squared over, but you don't know your density, but he tells you, okay, specific gravity. Okay, so there's his wording, and that's the symbol. So S, and I've been calling it SG, 0.92, which is equal to the density of this oil over the density of water, or since he has this expressed this way in SI, then the density of oil, okay, so I'll put an arrow like this and say the density of oil would be 0.92 times 1,000 kilograms per meter to the cubed, since that is the density of water. So all I did is I moved that up times it. Density of oil is equal to 0.92 times it, which means you get 920 kilograms per meter to the third. Now, anytime, or how should I say that? Anytime you have kilograms and newtons in there, I mean, the number is going to be the number. And so I don't know what I don't even know if oh,
Divided by.
here you go. Yeah, 0.1 divided by 920, does it end up being 1.09 e to the minus 4? That sounds about right.
1.0869. So yeah.
Okay.
If you round up 3
Yeah.
sig figs, yes.
Now, in these things, they want units too.
Yes.
So the units here are, this is the part that I was like, okay, now you got to stop here and think about this, because this is what you got, but you have a Newton stuck together with a kilogram, and you don't see either one of those, so you got to get rid of one of those. So Newton's law says a Newton is a kilogram meter second squared. Since F is equal to ma, if I just use that, then the top would be a kilogram, a meter. Now, gosh, there's a lot of stuff going here. So what I'm going to do, okay, this will cancel out, give me just a second. So what I'm going to do is do the top one, which will be, okay, so this will be meter, this one will cancel that, meter to the minus 1, a second to the minus 1, over, and this one would be a meter to the minus 3. It looks weird, but then you would come down one more, and then this minus 3 would be, move up on top, and it would be a meter squared, a second minus 1. which is what he ends up with. So the Newton killed off the kilogram, but gave you back a meter and a second squared. It ends up coming back down to that. So when he's asking,
That breaks down into unit conversion rather than actual
numbers,
numbers,
Yeah.
yeah. What I'm trying to say, like, it's just a unit conversion at the end of the day.
yeah. At the end of the day, it's not really a unit conversion, it's a unit alignment, you could say.
Unit equivalent.
Yeah, unit equivalence, that's even better. So that's an equivalent, so a Newton is equivalent to that. And anytime you see a force and a mass together, somebody's got to give. So to me, F is equal to ma, that's a convenient, I mean, it is true, m is equal to F over A, but it's more natural for me to kill off the force in lieu of getting a mass out of it. And that's what I did, and then got, but if I did it the other way, I'd get the same answer. So, but yeah, that one, this early section, he is using the units in there. I'm trying to see, okay, what's part B? Express your answer in 3. Oh, you're changing, now here's a unit conversion where you're changing feet squared and meters squared. Look at that, it's kind of weird. But if I touch it, it gives me the image, but. Oh, okay, so this tells me how many students total have you, I don't know when that is. So, okay, so if I go back, okay. Oh gosh, I don't even know. Some of these are fairly simple. Oh, okay. The tank has a liquid density of this. Okay, it says the same thing, tank has liquid. Determine the weight of the liquid when the level is shown. H, where's this H? Oh, H is equal to 3.5. So that's just taking the volume and then multiplying it all out. So you're just doing a 4 times 2 times H minus 1, that's how much fluid is in there, times the, so in other words, these are simple in a sense that if you had, again, gamma is equal to rho times G, which is equal to, in this case, it's this. So it's so many feet, I'm sorry, on the top, it's so many pounds per cubic foot. If this happened to be water, which I'm not sure if it is, oh, it tells you the density of the fluid. One. Yeah, so 1.22 slugs per cubic foot. So this would be 1.22 slugs per cubic foot times a gravity of 32.2 feet per second squared. And that would give you, you know, what it is, but your units, I don't know what that is, but you'd get a number, and that would be a slug. Okay, give me a second. A foot third, and a second squared. Now, that doesn't feel comfortable in this sense until you realize F is equal to ma, and a pound is equal to a slug, and a foot, and a second squared. So if I want to get rid of this slug, move that, it'd be a pound, second squared over a foot. So now if I stuck that in here and just stuck in the slug, which would be a pound, a second squared over another foot, which that is your slug, your units then become that foot, wait,
The second squared cancel each other.
yeah, second squared cancel each other.
Pound stays.
Pound
and
stay.
the foot cancels each other. So
Yeah.
then you're left with pounds over feet cubed.
Yeah, which is what you wanted. So that's, if you have so many feet, meaning in this particular case, if you had a cubic foot of a 2 by 4, the volume of this, h times h minus 1, that's equal to the volume in cubic feet. And so you should multiply that times this number, and then what you get is 1.22 times 32.2, and that's in pounds per cubic feet, times 2 by 4 by h minus 1, and that's,
3.5, right?
oh, is it? I don't know.
Yeah,
Oh, yeah, okay. And then I would just multiply that out. That would tell you how many pounds that's that bucket of, or square bucket of water.
That trough of water.
Yeah, trough of water. Most of the time, it's pretty heavy. Most of the time, it's really heavy. Most of the time, it's really, really heavy and can cause problems because it's so heavy. Yeah, let me get it.
85.68 pounds.
Okay.
Yeah.
Yeah, so if you scroll down, let's see if we got 786 is what it says.
Yeah. I got 785.68. Yeah, correct.
So that's actually just one of the problems right there. And then let's see, you can go, okay, so 111, I think it was similar. Okay, a tanker carries that many barrels of oil. Okay, so that tells you all that. You determine the weight of the oil if the specific gravity. Again, what you're doing there, you're converting barrels to gallons. I'm sorry, barrels to okay. Hey, let me write it down because sometimes things like this can be confusing, but there was a thing in I don't know if it was in this book or the other book, Power of One, which it actually is pretty cool. Barrel contains 42 gallons. One barrel, 42 gallons. So that's one. Then the other is, okay, so he says there are so many barrels. Well, I got 750 and 10 to the third barrels. But I want to flip that and say gallons, 42 gallons every one barrel. That gets rid of the barrels. And then I got gallons left, and then I got gallons per cubic feet. So I got 1 foot to the third equals 7.48 gallons. Right. So this cancels that. That cancels that. And so now I've got so many cubic feet of oil. So now I've got whatever that is, 750, 10 to the third, 42 divided by 7.48. And that's how many cubic feet. So if I want to know the weight, I'd put in the specific weight of so many pounds per cubic feet. But that comes from the next slide down. Says I think it said the specific gravity of the oil, which if you roll down, you'll probably find it's like 0.9 or something. Yeah. So if you
And
take,
that's for how much? The specific gravity is for,
it's the density of oil or whatever the substance is.
compared to water.
Right. And so now I know what that is. If I want to know that density, but it's also the same thing as if I multiply it times G, it's the gamma of oil over the gamma of water. And it turns out that we know that 62.4 pounds per cubic foot. We move it over, and the gamma of oil becomes 0.94, that, times 62.4, and that's pounds per cubic foot. So we take that number, and we stick in here. That tells you the total weight of all that oil, which is probably quite a bit of weight.
We would multiply it by that.
Right. And I think the next one, what? Why did I assign that one? Oh God, why did I do that? Okay, the water in a swimming pool is measured at a depth of 5 degrees. Okay, the depth of 3.8 meters when the temperature is that. For 5 degrees, okay, when the temperature is 5 degrees, it's that. For 5 degrees here and that, okay, so this is, man, this kind of sentence kind of runs together. Okay, temperature is 5 degrees, and then he repeats himself. Okay, so when the temperature is 5 degrees, period. Okay, so here's what he said. The water in a swimming pool is measured depth that when the temperature is 5 degrees, period. Then he says, that is for 5 degrees. And this is for 35 degrees. Okay, so then he's going to want to know what's determine the approximate depth of water when it's 35 degrees. So there it amounts to like an expansion, but in this case it's a contraction. Meaning the weight or the amount or the mass in the pool is the same. So in other words, the mass of the water is equal to fixed. It doesn't evaporate. So the density is the mass per unit volume. And then the question becomes, you could go back and say, I want to know the total mass in there. So the mass, whatever that is, it's in this much, equal to the volume times the density. When it's 5 degrees, no, or was it, did he say when it was 5 degrees? Okay, yeah, when it's 5 degrees, the height of water is that. So when it's 5 degrees, the volume is 3.08 by 9 by 4. That's how many meters to the cube there is. The density at the 5 degrees is 1,000. So that's that number. That's the mass. Now you change the temperature. So the mass remains the same. It's 3.08 times 9 times 4 times 1,000 equals to the volume, which is different. Is now the depth times the 9 times the 4, but this time the density changed to 9 94. So apparently, and probably going to go down very insignificant amount, but if you do this, depth is going to be equal to, and I'm interested in finding that out now. 8 by 9 by 4 by 1,000 over 9 by 4 OD by 9 by 4. Okay, never mind. Let me do that again. So, okay, so 9 by 4 by 994. But I also have to, okay, if this were 1,000, then D would be 3.8. But it's going to be not 1,000. And so, oh, do I have MATLAB up here? Now I've lost my problem. Oh, why am I worried about the problem? It's written on the board. Never mind. Okay. 3.08 is equivalent to times 1,000 divided by 994? Yeah. 3.9086. 3.9086. 3.10 or 3.9086. So, so if I subtract those two, 08, that's how many meters it came up. So actually, for every meter, for 1 meter, I think it's around 39 inches. Is that right? Okay, meter times 39. 0.72 inches. So it actually moved up a reasonable amount. So, did I do that right? So in other words, the difference of the two, that's the increase or decrease. And that's in meters. So yeah, it has to, so around, okay, so if I had so many meters, 0.0186 meters, and I wanted inches, around 39 inches equal 1 meter, somewhere around that. So that ends up being 3/4 of an inch, which actually is more significant than I thought it would be.
But that's not what the question was asking, or is that like part 2 of the question?
Oh, I was just, because he was wanting to know that we found that,
Yeah.
but to me, I just wanted to know, well, if you're standing out by the pool, how much did the water go up? And to me, I don't think in meters.
I got you.
I think in inches. So what I did is I took the increase, the 3.09, and took away the 3. So that's how many meters it went up. And then I was like, wait a minute, I don't know what a meter is, but if I multiply it times around 39, they get about 3/4 of an inch, roughly. I think it's about 39 inches per meter. I think it's 39 point something. I mean, you can find that out, but
Looks like Google can tell you.
yeah.
Yeah.
So those are the only ones that don't have, yeah, let me check that one. Is that the one I just did? Yeah, that's the one I just did. The rest of them are these are kind of cool. I mean, they're actually kind of neat, you know. You watch the video, and then you go in and you answer a simple question, you know. And then there's something like this one, another video, and you answer a question. And this one's similar. These little coaching things, they're actually, pleasantly surprised. And this one, oh, that's a coaching thing too. Yeah. So that, those are actually pretty good, actually. Better than I thought.
I just haven't had time to get to them yet.
Yeah. Well, I thought I'd run through them because I was running through them for the other guys, so,
I just haven't had time to get to it.
Yeah.
I'm gonna try to knock out of this weekend.
Yeah. Well, and this is Labor Day, right? I should have mentioned that last. I guess they knew not to come Monday.
Yeah, they know.
Okay.
Nobody's gonna be here Monday.
Oh, okay, good. I'm not either.
I don't